Have you noticed your electric bill creeping up lately? You're not imagining it. Something strange is happening to the power grid, and it has everything to do with artificial intelligence. While ordinary people are paying more for electricity every single month, the biggest technology companies in the world are doing something truly unprecedented. They're buying nuclear power plants, not leasing them, buying them outright. This isn't a coincidence. Your rising electric bill and their nuclear power purchases are connected by a problem that most people don't even know exists. Everyone talks about AI getting smarter, about regulations, about jobs being automated away, but there's a far more basic limit that almost nobody is discussing openly. We are running out of the electricity needed to power artificial intelligence. When people think about the limits of AI, they imagine problems of intelligence and consciousness. Can machines really think? Will they become aware? Will they surpass human capability? These are certainly fascinating philosophical questions, but they miss the point entirely. The actual constraint on artificial intelligence isn't philosophical at all. It's completely physical. It's about watts and joules, not wisdom and reasoning. Here's the brutal truth that most technology coverage ignores. Every AI query, every generated image, every chatbot response requires real electricity, not a small amount, a substantial amount. Training a single large AI model can consume as much energy as a small town uses in an entire year, and inference, which is the ongoing use of these models at scale, is even more demanding over time. The numbers involved are genuinely staggering when you examine them closely. Data centers already consume approximately 2% of all electricity generated globally. According to some credible estimates, we would need the equivalent of 3 entire Earth's worth of power generation capacity to scale artificial intelligence to its theoretical full potential. 3 Earths worth of electricity. Unfortunately, we only have one planet. The warning signs are already visible everywhere if you know where to look. Grid operators across the country are sounding urgent alarms. Power companies are scrambling to add capacity wherever possible. In some regions, brand new data centers are actually being denied power connections because there simply isn't enough electricity available to go around. This isn't some hypothetical future problem. It's happening right now, today. The stakes of this situation couldn't possibly be higher for all of us. If we can't solve the energy problem in the coming years, AI development simply hits a wall, not a metaphorical wall that can be overcome with cleverness, a real, physical barrier constructed of watts and joules and the fundamental laws of thermodynamics. The companies that understand this are already taking aggressive action. The ones that don't will be left behind. So here's the fundamental question that almost nobody is asking publicly. Where will all of this incredible amount of power actually come from? Solar and wind energy are growing rapidly, which is genuinely encouraging, but they simply cannot provide the constant, reliable baseload electricity that AI data centers demand around the clock. The real answer, it turns out, is being written right now in multi-billion-dollar corporate deals. Let's examine the actual numbers behind this situation, because when you see the underlying math clearly, everything becomes crystal clear. This isn't speculation, fear-mongering, or clickbait designed to generate views. These are official projections from grid operators, energy regulatory agencies, and the technology companies themselves. The mathematics of this situation is absolutely brutal, and unlike pundits and politicians, math doesn't lie or spin. To truly understand the scope of this emerging crisis, we need to start with an organization called PJM Interconnection. You've probably never heard of them before today, but they operate the largest coordinated power grid anywhere in North America. They serve over 65 million people across 13 states and the District of Columbia, and they just released a warning that should genuinely terrify everyone paying attention. PJM Interconnection now projects that it will be 6 gigawatts short of minimum reliability requirements by the year 2027. Let that number sink in for a moment. 6 gigawatts. That's the equivalent of 6 large nuclear power plants worth of electricity that simply won't exist when we need it most. This isn't some distant hypothetical future scenario. It's only 3 years away from today. And PJM certainly isn't alone in facing this challenge. An organization called Grid Strategies predicts that peak electricity demand across the entire nation could grow by 166 gigawatts by the year 2030. To put that enormous number into a perspective that actually means something, that's the equivalent of adding 15 entire New York cities to the electrical grid in just 5 years. For most of the last 2 decades, total U.S. electricity demand was essentially flat and predictable. Power companies across the country built their long-term plans around slow, steady, predictable growth that made planning straightforward. Then the AI revolution happened seemingly overnight. The demand curve that was reliably horizontal for years is now going almost vertical. The existing electrical grid simply wasn't designed or built for anything like this. Total U.S. data center electricity demand is projected to reach 134 gigawatts by the year 2030. That's nearly double what it was just 5 years earlier in 2025. Every single major technology company is racing at full speed to build more computing capacity, and every new facility they build requires significantly more electrical power than the last one did. Want to see clearly where this trajectory leads if left unchecked? Look at Dublin, Ireland as a cautionary example. Data centers now consume an astonishing 79% of that entire city's commercial and industrial electricity. Let me repeat that, 79%. That's absolutely not a typo. An entire major European city's power grid is dominated by computer servers. This is America's near-term future if we don't act decisively. Northern Virginia already hosts by far the world's largest concentration of data centers anywhere on the planet. A staggering 26% of the entire region's electricity goes to powering computer servers. Local utilities are visibly struggling to keep up with demand. New data center projects increasingly face delays, not because of permits or construction challenges, but simply because there's no available electrical power to connect them to. Here's precisely where this situation hits your personal wallet month after month. In the PJM regional electricity market alone, data centers accounted for an estimated $9.3 billion in wholesale price increases during 2025 alone. That enormous cost inevitably gets passed directly onto regular consumers like you and your neighbors. When giant technology companies need more power, ordinary people pay significantly more for electricity. Transmission companies across the nation are now spending many billions of dollars building out and expanding the electrical grid specifically for data centers. New high-voltage power lines, massive transformers, entire substations. All of this critical infrastructure costs enormous amounts of money, and according to leading energy analysts, more than half of all increased retail electricity prices come directly from rising power generation costs. Building new electrical power capacity is simply expensive. This certainly isn't just an American problem confined to our borders. The International Energy Agency officially projects that global data center electricity consumption will triple by the year 2035. That's an increase from approximately 460 terawatt-hours to an enormous 1,300 terawatt-hours. Every single country in the world with serious artificial intelligence ambitions faces exactly the same immutable physics. So where exactly will all of this massive new power generation come from? Solar panels covering fields? Offshore wind turbines? They certainly help contribute to the solution, but they simply cannot provide constant 24/7 baseload power reliably. The sun doesn't shine at night, and the wind doesn't always blow steadily. AI data centers require absolutely constant, completely reliable electricity around the clock. That fundamental requirement is where nuclear power enters the picture. Big tech has collectively made its choice for the future. Nuclear power is the answer. In the past year alone, major technology companies have signed binding contracts for more than 10 gigawatts of new nuclear generation capacity. That's 10 billion watts of continuous power output, enough reliable electricity to supply millions and millions of American homes indefinitely. The long-awaited nuclear renaissance has officially begun. Why are these technology giants all choosing nuclear power specifically? Unlike solar panels and wind turbines, nuclear reactors provide completely consistent baseline electricity that doesn't fluctuate unpredictably with changing weather conditions. A nuclear plant runs continuously 24 hours a day, 7 days a week, regardless of passing clouds or calm wind conditions. That's precisely and exactly what AI data centers absolutely need: completely uninterrupted, perfectly reliable power supply. Microsoft made major headlines with a stunning $16 billion 20-year power purchase agreement to restart the 3 Mile Island nuclear facility in Pennsylvania. Yes, that 3 Mile Island, the infamous site of America's worst nuclear accident back in 1979 that terrified the nation. They're officially renaming it the Crane Clean Energy Center. Nuclear history is literally being rewritten by a software company. Under this groundbreaking agreement, Microsoft will receive 100% of the restarted plant's total electrical output, a substantial 835 megawatts of constant, completely carbon-free power flowing directly to their data centers. The restart is officially targeting completion in 2028. This deal represents the largest corporate nuclear power agreement in American history, and remarkably, it's just the very beginning of big tech's aggressive nuclear shopping spree. Amazon certainly isn't far behind its competitor in the nuclear race. They've already secured 1.9 gigawatts of reliable nuclear power through the year 2042 from the Susquehanna nuclear plant in Pennsylvania. But that's not all they're planning. They're also investing well over $20 billion to convert the entire surrounding area into a massive AI computing campus. The future is literally nuclear-powered artificial intelligence. Meta has assembled an enormous nuclear power portfolio that could potentially provide enough electricity to power 5 million typical American homes. Their various deals potentially total more than 6 gigawatts spread across multiple partners, including Vistra, Oklo, TerraPower, and Constellation Energy. Mark Zuckerberg is clearly betting very big on atoms to power his metaverse ambitions, not just software algorithms. Google is pioneering something genuinely different from its competitors: the first U.S. corporate deal for an entire fleet of small modular reactors known as SMRs. Their innovative partnership with Kairos Power is designed to deliver approximately 500 megawatts by 2030 or shortly thereafter. SMRs are factory-built in controlled environments, easily scalable, and could potentially revolutionize how we deploy nuclear power generation going forward. Major technology companies collectively have concrete plans to finance more than 20 gigawatts of small modular reactor capacity in the coming decade. That represents an entirely new industry being built completely from scratch, funded by the wealthiest companies on Earth rather than by governments. The nuclear industry that was widely considered dying and obsolete just a decade ago is now being dramatically resurrected by artificial intelligence. Do you clearly see the unmistakable pattern emerging here? Microsoft, Amazon, Google, Meta, every single major AI company is independently making essentially the exact same strategic bet on nuclear. They've all reached the same conclusion through their own analysis: renewable energy sources alone simply cannot power the AI-driven future at scale. Nuclear is the only proven technology that can provide reliable, carbon-free baseload electricity at the massive scale required. We're watching technology companies transform themselves into energy companies right before our eyes. The software giants of Silicon Valley are becoming power players, quite literally in every sense of that phrase. They're not just passively buying electricity anymore from utilities, they're actively financing power plants, signing decades-long contracts, and fundamentally reshaping the entire energy infrastructure of the nation. This creates enormous opportunity for investors who understand. Here's something fundamental that most technology investors completely miss in their analysis. Software can scale infinitely at essentially zero marginal cost, but physical infrastructure absolutely cannot. You can copy a software program a million times for practically free once it's written. You cannot copy a power plant no matter how much money you have. Every single megawatt of capacity must be painstakingly built, wire by wire, turbine by turbine. This fundamental constraint creates a bottleneck in the system, and bottlenecks always create tremendous value for those positioned correctly. The companies that can successfully secure reliable power will ultimately win the AI race. The ones that can't will be permanently constrained in their growth. It's not about having the smartest AI algorithms anymore. It's about having the electricity to actually run them. Power has become the new competitive moat. Remember learning about the California gold rush back in school? History teaches us that the people who got richest weren't typically the miners digging for gold. They were the entrepreneurs selling picks, shovels, and supplies. The exact same logic applies perfectly to the AI revolution today. While everyone obsessively focuses on the algorithms and models, the real opportunity might actually be in the physical infrastructure that makes AI possible. What exactly are the picks and shovels of the AI gold rush happening right now? Power generation capacity, especially nuclear facilities. Transmission infrastructure, connecting everything together. Sophisticated cooling systems for data centers. Land strategically located near major electrical substations. Copper, high-voltage cables, massive transformers. Everything physical and tangible that software fundamentally depends on, but cannot create on its own. Total U.S. power usage is expected to climb at least 30% by the year 2030, with the overwhelming majority of that new demand coming specifically from data centers and AI computing. That's not gradual, gentle growth. That's a dramatic step change in an industry that barely grew at all for 20 consecutive years. Every single part of the energy supply chain must expand rapidly to keep pace. Transmission infrastructure is especially constrained and represents a critical bottleneck. You can't just build new power generation, you also have to reliably deliver that electricity to where it's needed. New high-voltage transmission lines take many years to permit, approve, and construct. The companies that already own transmission infrastructure are sitting on increasingly valuable assets that appreciate over time. Electrons need highways to travel on too. Strategic location matters far more than ever before in this new energy landscape. Land situated near major power substations has become extremely valuable real estate. Data centers absolutely need to be located close to where electricity is abundant and reliably available. Some of the most valuable real estate in America today isn't located in major cities. It's positioned right next to power infrastructure in rural areas.